Hello guys, welcome to Unacademy KCET YouTube live session. Myself Sharif, teaching IIT JEE Mains and Advanced Math from past 16 years, taught math in India as well as abroad, currently working as head of the maths department and vice principal of Giraffe Learning. Before I start guys, please do subscribe and enable the bell icon so that you get notifications of all my classes. Alright, and below the description box there is a link there. You can use that link to attend my special classes, that is free classes and plus classes on Unacademy platform, which I do this PYQs and other chapters in detail, guys. Okay, other concepts, previous year CET and Government K questions from 2004 to 2020, and all the connected topics and most important MCQs. I do in detail on that platform. And please do follow me on the app as well on Unacademy platform. And let me tell you about the Unacademy Plus subscription, guys. These are the best plans for KCET 2021 aspirants. In fact, for 2022 as well. For 12 months, it will cost you 12375, that is 1031 per month. Enter this referral code, you get 10% off. And 6 months, it's 10125, that is 1688 per month. With this referral code, you get 10% off and per month 2250. You get premium content at affordable price. Structured live courses plus dedicated live doubt clearing sessions, quizzes at regular intervals for self-analysis, batches for complete preparation, test series for DPPs, that is daily practice paper, full length mock with etc. with analysis. You get all this under single subscription, unlimited access. And this is the Maestros batch for KCET 2021 by the best educators in the country, guys. This batch was started on 15th of December, and this new batch was starting on Jan 5th as well. Alright, so do take up that batch, guys. Okay, so we have done up to question number 68. Okay, and let me remind you, this is PYQs of definite integral session 8. Up to session 7 I have done. If you have missed that live classes, guys, watch the recording on YouTube. All those classes are there. Alright, and we have done up to question number 66. So let me move to question number 67. So this is PYQ of definite integral, okay, and session 8. One moment, guys. Alright, now this is equal to integral 0 to pi by 4. Integral 0 to pi by 4 is divided by cos cube. I'll keep as it is. Okay, and then this 1 can be written as sin square plus cos square. Sin square plus cos square is anyways 1. Okay, and then this is plus sin square x dx. These are the PYQs of Comet K. Right, level of difficulty obviously one step more than the CET. So sines 1 I just wrote sin square plus cos square, and then I'm writing sin square x dx. Integration 0 to pi by 4. Okay, 0 to pi by 4, this is 2 sin square x. 2 sin square x plus cos square x and whole divided by cos cube x dx. Whole divided by cos cube x dx. So let me write this as integration of 0 to pi by 4. Okay, and then 2 sin square x. 2 sin square x divided by cos cube x divided by cos cube x dx. Okay, and then plus integration of 0 to pi by 4. 0 to pi by 4, and then you get this as cos square x divided by cos cube x dx. Right, divided by cos cube x dx. This is divided by cos cube. Okay, now this will be equal to 2 times 2 times integration 0 to pi by 4. 2 times integral 0 to pi by 4. This will be equal to sin square x divided by cos cube x can be written as cos square x, okay, into cos x, and then dx, plus integration of 0 to pi by 4. 0 to pi by 4 and 1 upon cos x. So integral 2 times integration 0 to pi by 4. Sin upon cos tan, so you get this as tan square x. This will be equal to tan square x. Okay, and 1 by cos will be equal to sec, you get sec x dx. Plus integration 0 to pi by 4. Okay, and 1 by cos is equal to sec, and then you get sec x dx. Now this is not going to help you out, guys. You can't integrate tan square into sec x. So what I'll do is, this is equal to 2 times integral 0 to pi by 4. Just note this step. I'm going to write this as sec x. Okay, and then into sec x tan x. I write this as tan x. Tan square x can be written, tan square x into sec x can be written as, okay, tan x, and then I will write this as sec x tan x. Both are same, right? You multiply, again you will get this tan x into sec square x. I just wrote tan square into sec x as tan x into sec x tan x. Both are same. Okay, and then plus integration 0 to pi by 4. 0 to pi by 4 and then sec x dx. Good question. Okay, very challenging. Now I'm going to write 2 times integration 0 to pi by 4. 2 times integral 0 to pi by 4. This is tan x. Tan x can be written as root of sec square x minus 1. Root of sec square x minus 1, and then here I get sec x tan x. Sec x tan x dx. That's right. Tan square, so tan x is root of sec square x minus 1 into sec x tan x dx plus integral 0 to pi by 4. Okay, plus integration 0 to pi by 4, and then you get sec x dx. Okay, now this equal to 2 times. Note the step, guys. In the first part, I'm going to put sec x is equal to t. Differentiation of sec x is sec x into tan x dx. Sec x tan x dx is equal to dt. Okay, even the limit will change. Let's call equation 1. When x is equal to 0, when x is equal to 0, t is equal to sec 0. Okay, and sec 0 will be equal to 1. Yes, good morning, Prakash Raj. When x is equal to pi by 4, guys, when x is equal to pi by 4, you will get t is equal to sec of pi by 4. Okay, and sec 45 is equal to root 2. So new limit will be equal to integration of, when x is 0, t is 1, when x is 45, t is root 2. This is the root of t square minus 1. Okay, and sec x tan x is equal to dt plus integration 0 to pi by 4. Okay, and then this is equal to sec x dx. 0 to pi by 4 and then sec x dx. Now this can be written as 2 into a bracket. 1 is same as 1 square, na? Okay, so I'm going to use the formula integration root of x square minus a square. Root of x square minus a square special integral will be equal to x by 2 into root of x square minus a square. Okay, minus a square by 2. Minus a square by 2 log of x plus root of x square minus a square. And then plus c. So let us use this formula, guys. Okay, let me use the formula. So you get this as t by 2 into root of t square minus 1. Okay, minus t square by 2. Minus t square by 2 minus x square by 2, and then you get, good morning Raju, log of t plus root of t square minus x square. T square minus 1 between the limits 0 to root 2. Okay, and then integration of sec x will be equal to log of sec x plus tan x. Log sec plus tan log of sec x plus tan x between the limit 0 to pi by 4. Okay, so let me simplify this, guys. Log of sec x plus tan x, log sec plus tan between the limits 0 to pi by 4. Okay, now if you open the bracket, 2 and 2 cancels, you get t into root of t square minus 1 between the limits 0 to root 2. Okay, and then between the limits 0 to root 2, again 2 will cancel with 2. If you open the bracket, you will get this as t square into log of t plus root of t square minus 1. T square minus 1 between the limit 0 to root 2. T square minus 1 between the limits 0 to root 2. Plus this will be equal to log of, if I substitute upper limit, you get root 2 plus 1, sec 45 root 2 tan 45 1. And if I substitute lower limit 0, sec 0 1 tan 0 0, you get log 1. Anyways, log 1 to any base is 0. Okay, now if you substitute upper limit, you will get root 2. Okay, and root of 2 square minus 1 will be 1 only. Okay, minus into a bracket. Upper limit, if I substitute, you get 2 into log of, 2 into root log of, okay, root 2 plus 1. Root 2 plus 1. Okay, and lower limit will be equal to, if I put t as 0, obviously this will be 0. I open the bracket, you will get x by 2 into root of a square minus x square plus a square by 2. Plus a square by 2, a is 1 only, guys. Here plus a square by 2 is 1 by 2. Right? So plus a square by 2 is 1 upon 2. You open the bracket, you still get 1. So there is no 2 here. If you open the bracket, it is upper limit is root 2 minus 1. Okay, upper limit is root 2 minus 1. Lower limit is, you get log. Lower limit, if I substitute t as 0, you get log 1. Lower limit in place of t, it is actually 1. Okay, so if I substitute lower limit, this is equal to, okay, this will be 1. You open the bracket, this will be 1, right? And then this will be 1. This will be 1. Anyways, lower limit will be 0. Right? Now, Raju, this is Comet K question. Okay, minus, very good question, challenging problem. Log of root 2, okay, and 2 minus root 2 minus 1 is 1. Minus lower limit will be equal to log 1. You understand? Log 1 to any base is 0 anyways. Plus this is equal to log of root 2 plus 1. Okay, now if I simplify, guys, this will be equal to root 2. Okay, and then this is log of root 2 plus 1. Log of root 2 plus 1, and then this is plus log of root 2 plus 1. Okay, this anyways, this fellow will get cancelled. Answer will be equal to root 2. So this will cancel. You will get this as root 2. That's the answer, guys. Right, answer will be equal to option C. Is it okay? Let's move to the next question, guys. Okay, if box x denotes the greatest integer not exceeding x, greatest integer less than or equal to x, then what's the value of this integral? Alright, now let me split this. This can be written as integration of 0 to 2 can be written as 0 to 1. 0 to 1 x into cos of box of pi x. Box of pi into box x dx. Okay, and then 0 to 1, and then I'll write 1 to 2. Okay, 1 to 2, and then you will get this as cos of x into cos of pi into box x. Okay, and then dx. Now let us integrate. Between 0 and 1, box x is 0. So this becomes integral 0 to 1 x into cos of pi into 0, because box x is 0. Okay, and then plus 1 to 2. Between 1 and 2, between 1 and 2, box x is 1. X into, this is cos of pi. Okay, and then dx. Now this is equal to integral 0 to 1. Okay, x into cos pi cos of pi into 0 will be 0. Okay, and then this is 1 to 2, and then you get x into cos pi is minus 1. Okay, and then here cos 0 is 1. Right, now if I integrate this, okay, now if I integrate this, it's equal to integration of 0 to 1. Cos 0 will be 1, you get x into dx. Okay, minus out integration of 1 to 2 and then x into dx. I integrate this, I get the answer. Okay, integration of x is x square by 2. X square by 2 between the limit 0 to 1. Okay, and integration of x is x square by 2 between the limits 1 to 2. Half is a constant out. Okay, upper limit 1, lower limit is 0. Minus 1 upon 2. Upper limit 2 square 4, lower limit is 1. So this becomes 1 by 2. Okay, minus 3 by 2. That is equal to minus 1. That is minus 2 by 2. Okay, answer will be equal to minus 1. Answer is option B. Is this okay, guys? Answer will be equal to option B only. Yeah, right. Next, let's move to the next question, guys. Right, limit x is tending to 1. Limit x is tending to 1. Okay, I can write this as 4 to f of x. 4 to f of integral 4 to f of x, and then this equal to 2t. Okay, and then whole divided by x minus 1 dt. Comment K question. Right, now if x is tending to 1, actually f of 1 is equal to 4, right? So lower limit and upper limit will be same. So this means that this is of the form 0 by 0. Right, x is tending to 1, you will get integral 4 lower limit 4, upper limit f of 1. F of 1 will be 4. Indefinite, if lower limit and upper limit is same, then it is 0. Yes, we should use L'Hopital's rule. Okay, and then when you differentiate the numerator, you should use Leibniz rule. So what is Leibniz rule, guys? You have to differentiate. What is Leibniz rule? Differentiation of a definite integral. Whenever if I example, if I take, let's say if I take like this. Okay, integration of d by dx of, if I want to differentiate, integration of x square, okay, and then x cube, and then e to the power of t dt, something like this. If I want to differentiate the upper limit, differentiate the upper limit, you get 3x square. In place of t you put upper limit. Differentiate the upper limit, in place of t you put upper limit. Okay, Leibniz rule, minus. Okay, minus differentiate the lower limit, in place of t you put lower limit. Okay, so same logic, guys. If I differentiate this, so limit x is, if I use L'Hopital's rule, okay, so limit x is tending to 1, differentiate the upper limit, in place of t you put upper limit, you get 2 into f of x. Okay, minus differentiation of 4 is 0, because anyways that's a constant, and when you differentiate the denominator you get 1. Now if x is tending to 1, okay, if x is tending to 1, you get this as f dash of 1. F dash of 1 into 2 into f of 1. Okay, now what is f dash of 1? F dash of 1 is equal to 2 plus into 2, right? And f of 1 will be equal to 4. You multiply, you get plus 16. That's the first option, isn't it, guys? Yes. Answer will be equal to option A only. Yeah, let's move to the next question, guys. Okay, first we will find out. Yeah, in JEE there was a similar question, correct? So we will first find out what is x1, x2 are the roots of this equation, guys. So let us first find x1 and x2. So it is given in the question that 6 times integral 0 to x, 6 times integration 0 to x, and f of t is already given. So if I substitute here f of t will be equal to t square minus 3t minus 4. T square minus 3t minus 4, that's already given, and then this is f of t. Okay, and that's equal to 2x cube minus 8x square, okay, minus 27x, and plus 2. Okay, now 6 times integration of t square is t cube by 3 between the limit 0 to x. Okay, and then this is 18. If you open the bracket, it is 18 integration of t is t square by 2 between the limit 0 to x. Okay, minus 6 fourths 24 integration of dt is t between the limit 0 to x. Okay, is equal to 2x cube minus 8x square minus 27x. Okay, and then plus 2. So this will cancel anyways. 2 times upper limit is x cube minus 9 times upper limit is x square, lower limit is anyways 0, minus 24x. Okay, if you shift on the left side, you get minus 2x cube plus 8x square, okay, plus 27x, okay, minus 2, and that's equal to 0. Now anyways this will cancel. Okay, now if I simplify, guys, okay, let me simplify this. So this becomes integration of, okay, this becomes integration of minus x square, 2x square minus x square, okay, and then you get plus 3x minus 2 equal to 0. Change the sign, you get this as x square minus 3x plus 2 is equal to 0. If you split the middle term, you get x minus 1 into x minus 2 is equal to 0. So roots are x is equal to 1, x is equal to 1 and x is equal to 2. Is it okay? So x1, x2 are the roots of this equation. Roots are 1 and 2. Now with this roots, I am supposed to evaluate, or I am supposed to find the value of modulus of 6 times integration of, see the question, x1 to x2. These are the roots, x1 and x2, and then you get f of t dt. Very good question. And then you get f of t dt. Okay, so this is equal to 6 times integration roots of 1 and 2, isn't it? Just now we found out, guys, roots of 1 and 2, and f of t is already given, t square minus 3t, t square minus 3t minus 4, right? And then this is dt. There's a mod here. Okay, so this is equal to 6 times, let me find the value here. How much is this? Integration 1 to 2 t square minus 3t minus 4, and then dt. Integration of t square is t cube by 3 between the limits 1 to 2. Integration of dt, t is t square by 2 between the limits 1 to 2. Okay, between the limits 1 to 2, and integration of dt is t between the limits 1 to 2. So 1 upon 3, upper limit is 2 cube 8, lower limit is 1, so you get 7 by 3 minus 3 by 2. 2 square minus 1 square will be equal to 3, minus 4 upper limit minus lower limit. So you get this as 7 by 3 minus 9 by 2, okay, and minus 4. You take LCM 6, you get this as 14 minus 27 and minus 24. So this is minus 37. Minus 37 upon 6. So if I substitute here, you get minus 37 upon 6. Okay, and there's a mod here. This will cancel. Mod of minus 37 is plus 37. Okay, so answer is option C. You understand, guys? So good question. It's a Comet K problem, guys. Right, where you need to find out the roots of x1 and x2, and then use that in the use that in the equation and take the values. Okay, so another one class, guys. I one more session. 1 2 3 4 5. Yeah, one more session, guys. We will complete this. Okay, and then I will do the PYQs of the differential equation and application of integrals. In the next session, guys. Next following sessions in this particular month. Okay, so one more session on the 5th. I'll try completing this, guys. Alright, and then we will do PYQs of application of integral, and then we will do differential equation. Please do watch, like, and share my video, guys. Please subscribe and enable the bell icon so that you get notifications of all my classes, guys. Alright, so I wish you all the best, guys. So take care, have a nice day. Alright, bye, guys. So I'll meet you on 5th of this month at 11:30 AM in the morning. Bye, guys. God bless you.